Good evening all, and welcome to the fourth cohort of the Blockchain Foundation program. Myself Nikhil V. Chandran, Research Engineer at Kerala Blockchain Academy, and welcome to the introductory session for the cohort 4 of BFP program. Let us discuss in brief about what this program is and what KBA is, and later let us discuss about the introduction to blockchain. So this is just a brief session on the basic ideas of blockchain and to get you acquainted with the program. About Kerala Blockchain Academy, it is an initiative under the government of Kerala for offering blockchain training in multiple domains, and we have training programs in Ethereum and Hyperledger and developer programs also. We also have industry collaborations and projects in our development team, and we have research collaboration and innovation clubs. Now coming to the BFP course. So what is the BFP course all about? It is a free online self-paced learning course. That means it is free for anyone to enroll and access the course. It is completely online and self-paced, meaning you can complete it within a specified time limit at your own pace. So there is no instructor interaction. I mean, instructor-led. It's not an instructor-led program, but it's a free self-paced program. So it will cover all the blockchain fundamentals, and you will get 1 month free access to the course content. In total, there are 4 quizzes, and you will have 2 attempts for each quiz. So that means for first quiz, you have to qualify with minimum 60% marks, and then you will get access to the second quiz. So you have 2 attempts to get that 60% marks for each quiz. Then after that first quiz, then you can get to the second quiz, and after the second quiz, you can get to the third quiz with a 60% mark. And finally, if you complete the fourth quiz with 60% mark, then you will get the certificate. Also, you can post queries on the discussion board. So the discussion board is available on the course page, and you can use the discussion board to ask questions and clarify your doubts regarding the course. So this cohort that will end on November 30th at 3 p.m. So that means you have the course content access from November 1st, that is today, to November 30th till 3 p.m. Till that time, you have the time to complete all the 4 quizzes with minimum 60% mark. Then you can get the certificate. So this digital certificate will be issued on blockchain after the course completion. So just after you complete the course, you will receive the certificate. So after November 30th. So this is about the BFP course. It is free for anyone to enroll and access. So those who enrolled in October, they will get access in November. So from tomorrow onwards, we will start the December cohort enrollment. That means those who want to access the course from December, they can enroll from tomorrow. So those who already have enrolled for this course, you will get 30 days or 1 month time to complete the course till the deadline, that is November 30th at 3 p.m. Now in brief about the course content. So there are 4 weeks of course content in this particular free course, and we will just discuss the main topics that are present in these 4 weeks course. So week 1, we have the introduction to blockchain. What is a blockchain, the history and the evolution of blockchain, how blockchain came about, what led to the revolution of blockchain, why is it relevant. Then the blockchain story, the history of currency, the need for decentralization. Why was it that the decentralized system gained in popularity? Then we move on to week 2 content, where we have the introduction to Bitcoin. So we will discuss in that week 2 content what is Bitcoin, the working of Bitcoin, the first blockchain, the application of Bitcoin, and why is it known as a digital gold. The different consensus mechanisms that are used in blockchains will be discussed in the next part of week 2. That is the proof of work, proof of stake, practical Byzantine fault tolerant, and some other algorithms also. So these are the contents of week 1 and week 2, where you will get to know the basics of blockchain, and you will understand what Bitcoin is and some consensus mechanisms that are used in blockchain. In week 3, you will get access to introduction to Ethereum and the Ethereum world computer, what is known as smart contracts and decentralized applications, and the programmable blockchains will be discussed. Then we move on to the content of Hyperledger, where it is known as a permissioned blockchains. So concept of distributed ledgers, the Hyperledger based projects and tools, Hyperledger Fabric will be discussed in week 3 content. Week 4 content, you can access the blockchain use cases in banking, supply chain, healthcare, and government. So these are only some of the areas in which blockchain has the potential to disrupt the traditional form of in these areas. Now, we also discuss the future with blockchain in brief about the current blockchain trends and the current challenges that are happening in blockchain, the scalability issues, and so on. So the last 2 weeks we will be discussing about the different kinds of smart contracts based programming and the use cases and the scalability issues. So we also offer programs in Ethereum for developer programs in Ethereum and in Hyperledger Fabric. So this is about the course content for the 4-week program. This is all self-paced, meaning you can study at your own pace and learn all the contents. And after each week content, there will be 1 quiz, and you will have to get minimum 60% to qualify for the next quiz. So after you finish all 4 quizzes, you will get certified, as I previously mentioned. Now, I don't plan to take this as a lecture kind of thing. So this is just a brief overview of what blockchain is. So just to get you onboarded onto this course, so to get you aligned with the ideals of this course, I will just give you a brief introduction in a few minutes about what blockchain is, and then we will wind up the session. So let us introduce blockchain. So before we go into describing what a blockchain is, let us discuss about centralized, distributed, and decentralized networks. So a network means a group of connected systems that are interconnected by some means of connectivity. So in this scenario, we are discussing about 3 types of such networks. So one is centralized networks, other one is distributed networks, and other is decentralized network. So simply it means these dots represent some computers, and the smaller dots, they also represent some other computers or mobile devices, anything that can connect with the internet. And these lines represent some internet connectivity or some kind of network that exists between them. So this dot represents some computers and the lines represent the connection between them. So in centralized network, there is one central authority or central server that is controlling the entire network. From that central server, all the other computers are connected to that central server. All the other nodes are connected to the central server. So that is the concept of a centralized computing system. So that is different from a distributed based systems, where we have a group of, instead of just one central server, we have small clusters of centralized authorities or controllers. So this small server or this controller will control one small portion of that network, and another another central controller will control another part of that network. So this is a fragmented or a distributed kind of network. It is connected via all the linkages in a peer-to-peer manner, like in a torrent kind of system, but still it is not each node does have some of the nodes have some privileges. Each node are not equal. So that is a distributed kind of system where there is a collection or a group of central controllers controlling some parts of the network. Now we come to the decentralized kind of networks, which blockchains are based upon, or public blockchains are based upon. So decentralized kind of networks, they are not, there is no controller. So notice that there is no hand. So that means there is no controller or controlling authority for such kind of decentralized network. So that means this network contains different nodes which are all having equal privileges. So these nodes are connected in a peer-to-peer manner. It means they are connected to each other, and all these nodes have no single authority or server controlling them. They have equal privileges. So that is the meaning of decentralized network, meaning there is no central server or any server is controlling these computers. All the computers in that particular network have equal privileges. So that is the difference between centralized, distributed, and decentralized system. So a blockchain is based on, public blockchains are based on decentralized kind of systems, and distributed ledgers are based on distributed kind of systems. So that is the difference between these three. So most of the public blockchains like Bitcoin and Ethereum, they are based on decentralized kind of systems where there is no single central server that is controlling the entire network. All the nodes in that particular network have equal privileges. Now moving on to the concept of a blockchain. So what is exactly meant by a blockchain? It is something, it is decentralized and it is public. So a public blockchain means anyone can have access to that network. It is decentralized, and there can be documents or records or votes or anything can be stored on that particular blockchain. And it's an open ledger to store this information that anyone can view. So it is similar to an online newspaper in the sense anyone can come in and view the records and verify the records in an open manner. So a public decentralized storage of value is known as a public blockchain. So we can store many kinds of documents or records or money or such kind of valuables, votes, etc. in a public blockchain. Okay, so next we consider blockchain where everyone have the same copy of this ledger. So this means you saw that in decentralized network there are multiple nodes, and these many computers or node, they have same privilege. So they have the same copy of this ledger in public blockchains. That means they are distributed and decentralized. Distributed means they are not geographically confined to one single location. They may be spread across the world in different locations, and they are also decentralized. Decentralized meaning they are not, no single central authority is controlling the network, and they have equal privileges. So this kind of distributed and decentralized kind of network is known as a public blockchain, and they maintain the same copy of this ever-growing ledger, ever-growing because as more and more data comes into the ledger, the ledger keeps on growing. So it is a dynamic kind of network where more and more transaction data is coming into the network, and the ledger keeps on increasing in size, and it is not confined to one single geographical location. It is distributed across the world, and it's not controlled by a single central authority or a group of central authorities. It is decentralized, and it is a peer-to-peer network like a torrent kind of system where each node is connected to a variety of other nodes in a peer-to-peer manner. In a peer-to-peer means from one node to another, direct connection exists. So this is known as the peer-to-peer distributed and decentralized ledger, which maintains the same copy of the ledger. So this is known as the future internet or the blockchain. So what is the advantage of blockchain? It is very hard to tamper or attack such kind of networks. We will see how it is in brief in the next slides. So we have to we cannot edit, or we have to edit and delete at each copy. So even if you edit in one copy, all the other copies will have the correct information. So you cannot tamper it in that way. So for anyone to to tamper or attack a network, they have to edit all the copies in the network. So that is a very tough task. So that is practically impossible. So that is why it is very hard to tamper or attack a blockchain. Now, going to the concept of a blockchain, how is a blockchain formed? So unlike storing the data into a single book or database, a blockchain is distributed and decentralized across many parties over the internet. So it is an immutable global book of trusted transactions. So that means we have many blocks here, right? So these blocks represent a block of different transactions that are occurring in that particular network, and they are connected or linked together via a cryptographic linkage. So this is known as a block of transaction, and cryptographic linkage known as chain. So a block of transactions and cryptographic chains together, they form the word blockchain. So these cryptographic linkages, we will see in brief in the next slides how these cryptographic linkages are happening. So that is how the name blockchain came about, chain of blocks. So that was first described in Bitcoin white paper by Bitcoin creator, whoever here they are. So Satoshi Nakamoto was a pseudonym, and Satoshi released a white paper of Bitcoin, and in that white paper they described the chain of blocks. The first description of the chain of blocks was done in that white paper, and they describe it as a group of transaction grouped together into a block and connected cryptographically by means of some cryptographic techniques known as hashing. So not going too much into detail, now we will just see some other aspects of blockchain. So breaking it down, how blocks are formed and how a blockchain is formed, we can consider the pages as individual transactions in the network, in the blockchain network. And these pages are collected for some time and they form a book. So these books can represent the blocks of transactions. And some pages, maybe for 10 minutes, all the pages are collected and they are grouped together to form one book. And that book is kept by different persons in the network. And these different persons represent the individual computers or individual nodes in the network. They are connected in a decentralized network, and these nodes keep the copy of the block. So everyone keeps a same copy of the block. So the transactions are grouped into blocks and the blocks are kept by the node. So nodes are computers in the network and they keep all the transactions. So after some time, after 10 minutes, then 11th minute to 20th minute, another so many other pages will come. Those will be grouped together. They form another block, and that blocks will be taken and it will be added to the existing chain of blocks, and they formed a chained link of blocks similar to the previous figure. So each node will have this kind of data structure in their ledger part, and this is maintained by each and every node in the public blockchain network. So this is known as the blockchain. And how we can analyze a blockchain analogy with that of a book, pages forming the transaction, books forming the blocks, and the persons, they are forming the nodes in the network. Now, seeing what is inside the block, just a little bit into detail of what a block consists of. So a block consists of a header part and a body part. So in the header part, we have some block information like some block numbers, previous block hash, some Merkle root, nonce, creation timestamp, etc. And the body part, we have some data. It's usually transactions data will be kept in the body part. So the header part, we can see there is something known as a previous block hash. So this is what gives the name of the cryptographic hash linkages. So here the second block is connected to the first block by the previous block hash, the third block to the second block, and the last block to the second last block by the previous block hash. So the hash of this block is taken and it is kept in the next block as a previous block hash. So that is how we get the previous block hash value. So there is something else known as Merkle root to keep the state of the system. So you can read more about that in the course. We have some nonce value, creation timestamp, and block number, etc. So these are all the contents of the block. So what is hashing? So hashing is a one-way mathematical function. So we input some text and input some text into the hash function, and we get some output. So the advantage of this is that it is difficult to generate but easy to verify. So one-way hash function, like we have the secured hash algorithm that is used in most of the blockchains, and that algorithm, it will take in some maybe any string values or any kind of value, and that value will be converted to a hexadecimal number, and this number is even if one single character changes. Like in this example, the cat with the capital C generates a hash that is this, but a cap with a small case to C, it will generate an entirely different hash. So the hash value that is generated by the algorithm, it is impossible to regenerate the input from this output. So this is the output value of the hash value, and this is the input value of the hash. So we cannot generate the input from the output. So it is known as a one-way mathematical function. So that is known as the hash function, and this similar kind of hash mechanism is used to connect the blocks via previous block hash value. So the previous block's hash is taken and it's stored in the next block as the previous block's hash. So the advantage here is that even if some tampering takes place, even if one character changes in the previous in one block in any transaction, then the previous block hash calculated will be an entirely different value. So we can identify that tampering has taken place somewhere in the transactions simply by checking the previous block's hash. So that is another way of maintaining this tamper-proof network. So this previous block hash enables that functionality. So let us define a chain. So what is this blockchain? It is a decentralized, distributed, immutable ledger technology. It is decentralized because we have seen the concept of decentralization. It no single central server is controlling the network, or a group of centralized servers are not controlling the network. Each node have equal privileges. So that is known as a decentralized network. It is distributed in the sense it is not confined to one single location. It can be spread across the world. Anywhere in the world there can be nodes, and hence it is distributed. It is immutable ledger. So what is meant by the immutable ledger? So idea of the immutable ledger here is that once a transaction is committed onto the blockchain, it cannot be modified. So this blockchain is a kind of data structure where you can only input the data, and once it is confirmed, then you cannot modify, edit, or delete the data. It is a permanent storage of, it is a record storing kind of system where you cannot modify the already stored records in the blockchain. So that is meant by the immutable ledger. So how can you change the value of a particular any variable in blockchain? So suppose you are storing a value, say x value equal to 10 in a block, in block 1. In the first block you are storing the value of x, a random variable x, as 10. Now after some time, now the current block is 10th block, and you want to change the value of x to 100. Now you cannot go back to the first block and modify the value of x to 100 there. You have to change the value and create a new transaction and set the value of x as 100. and that will change the state of value X from 10 to 100. And once it is confirmed onto the transaction, then from the 10th block onwards, the value of X will be changing from 10 to 100. So that is known as changing the state of that particular variable. So you cannot physically go and edit the previous block content or value. You have to change the state and thereby change the value of a particular variable. So that is known as the immutable ledger. Now, why do we need this blockchain? It is used for a different variety of use cases, like for recording any type of transactions or data with no single owner. So there are a variety of use cases for blockchain. It is being considered for banking, supply chain, financial, and other kind of scenarios. And it is being researched upon for further kind of use cases. So when did the concept of blockchain come, or when did blockchain as a technology begin? So it began with the creation of Bitcoin in 2008 by Satoshi Nakamoto. First, the white paper was released in 2008, and then the main network was launched in 2009. So Bitcoin, a peer-to-peer electronic cash system, was the white paper that was published by Satoshi, and it describes the chain of blocks, and that chain of blocks later came to be known as the blockchain that is used by many different kinds of technology these days. So what are some of the use cases of blockchain? So one of the prominent use cases of blockchain is in the banking sector. So there are a lot of unbanked population in the world, like more than 1.7 billion adults are unbanked, and over 200 million micro, small and medium enterprises are without access to banking services. So blockchain can enable maybe creating opportunities so that these population can have access to the some kind of digital banking solution. So that can be enabled by a blockchain powered technology, because most of these people, they have mobile phone penetration, or they have the mobile phones with them, but they don't have a bank account. So these people can maybe use a wallet kind of application or use blockchain based solutions and have access to a kind of digital mode of payments. So that is the idea of blockchain, one of the use cases where we are trying to bank the unbanked population of the world. There are also various other use cases, like in supply chain, or in vaccine traceability, or in many different use cases are being researched upon. So finally, we are coming to the blockchain variants. So we have two kinds of blockchains. Basically, we can consider permissionless blockchains, like the ones that you see that are famous, like in Bitcoin and Ethereum. They are anyone can join the network and participate in the consensus mechanism. So that means there is no restriction. They are pseudo anonymous. Then there is no need to prove the identity of the participant. We have some kind of consensus mechanism that is used, like proof of work, that is used to prove that order of the transaction is maintained. And we have some kind of permissioned blockchains also, like distributed ledger technologies that are used for consortiums or for enterprises. So these are using not so much computationally expensive consensus mechanisms like PBFT, Raft, or Paxos. So because only approved actors participate in the consensus, there is no incentivization required in the form of cryptocurrencies. And some of the examples are Hyperledger or Cohort. So these are the two kinds of blockchain variants. One is permissionless or public blockchains, and the other is distributed ledgers like Hyperledger or Cohort. So you can read more about them in the course. So finally, thank you for listening in. So to conclude, let me reiterate that you have the privilege of accessing the content from today till November 30th, and try to complete all the quizzes and get the certificate. And that's it from my side, and all the best.